to do is to plot the graph. Based on the equation given, you will find that x plus 1 equal to 2, so x minus 1. Solving the equation, we get you x equals to 1 and x equals to 5. By substituting of the each x into any of the equation, you will get y equal to 0 and y equal to 4. The graph will intersect at 1, 0 and 5, 4. From the plotted graph, we can see that there is an enclosed area between the two functions. To get the solid of revolution, we need to rotate vertically, since the equation gives x equals to 1, and so the cross section area will be function of y. That's called washer. We have two ready. This also means that we need to rewrite the functions in terms of y, which gets us x equals to y over 4 power of 2 plus 1 and x equals to y plus 1.
The functions are the distances from the y-axis to the edges of the rings. However, the center of the ring is a distance of 1 from the y-axis. This means that the distance from the center to the edges is a distance of 1, and then from the y-axis to the edge of the rings. So, the radii are the functions plus 1, which will get us outer radius and inner radius. That means the area of the washer, that is a cross-section of the solid, will be the larger circle, which is pi in bracket y plus 2 power of 2 minus the smaller circle, pi in bracket 1 over 4y power of 2 plus 2 power of 2. Next, just integrate the area of the washer from 0 to 4 and pull the pi out of the integral to get 4y minus y power of 4 over 16 dy. Integrating 4y will get us 4y power of 2 over 2. To simplify it will get us 2y power of 2. Then, integrating y power of 4 over 16 will get you y power of 5 over 80. By substituting y equals to 4, we will get 96 over 5, while for y equals to 0, we will get 0. By multiplying the answer with pi, the volume is equal to 96 over 5 pi. That's all.
To determine the volume of solid ring using shell method, the first thing we must know are the shell radius and the shell height. The radius of each cylindrical shell is horizontal distance from the current x value to the axis of rotation. From the equation, the axis of rotation is x equal to -1, so the shell radius is going to be x plus 1, since the axis of rotation and y-axis has distance of 1. For the shell height, we have to find differences between fx minus gx, which is fx to set x minus 1 minus gx, which is x minus 1. Next, we need to find the limit of integration. When we solve the equation, we will get the limit of integration, which are x equal to 1 and x equal to 5. Since the base shape of x-axis, we take the value of x-axis as the limit, which from 1 to 5. After that, we put all the information that we get into the shell formula for revolution about a vertical line. Formula volume for shell method, which we will get as V equal to, since 2 pi is a constant, we can take it out from the integration parts. We expand both equations together to get the final form, which is
the next step, we need to do the integration by substitution or change of limit by let u equals to x minus 1. Then we differentiate all the equation until we get du over dx equals to 1, so du equals to dx. After that, we need to find the u values by using the same equation, and we substitute the x by x equals to 5 and x equals to 1. Then we get the u values, which are u equals to 4 and u equals to 0. Then the u values become the new limits of integration. We also have to substitute the equation that we do just now into the integration part, which will get us this. To solve this, we substitute the value of limits to the equation, and the upper limit must minus the lower limits, just like this. Finally, after we solve it, the final answer will be 96 over 5 pi. So that is how we use the shell method to find the volume of solid ring.